we'll go ahead and get started, and people can join as they do. But I wanted to state this is our last seminar speaker of the year, and I am so very excited to have Idali Odebelu. Is that right?
Odebella. Yeah.
Odebella. Okay. Come talk to us today. And she has done so many things and is so active in AI accountability and in Twitter. And she just has done absolutely everything that I cannot begin to explain it. But I mean, she not only works in AI, but she started her own company and works as a LinkedIn instructor, and like just this week published her own book about getting started in data science. And so she is just absolute incredible powerhouse in data science and AI and algorithmic accountability. And so I've been looking forward to this talk all semester. And so I don't want to give it away. So, but before she gets started, I do want to plug our Hawaii Data Science Institute's holiday showcase, which is next week. And so if you haven't already seen the registration link for that, then we will put that in the chat by the end of the talk. And we usually do these without interruption, but that is completely up to you. If you want to have people raise their hands or anything, we're happy to have the seminar as formal or informal as you like.
Awesome. Thank you. That was like an amazing introduction. Thank you so much. Please feel free if you guys want to like raise your hands and ask questions, please feel free to. I'm more than happy to like stop, chat for a second. But yeah, I'll just like get started. So I'm Idali Odebella. Currently, I'm working at a company called Samba Safety. So we are working to improve basically road behaviors of drivers. So like distracted driving, trying to curb all of these things using a ton of different tools in machine learning. So I work on building new ML systems such as like driver risk scoring, as well as doing NLP-based like policy comparisons for our product teams. In my free time, I'm a data science mentor, chairwoman of the Black Girl Hockey Club, and member of Black in AI and the National Society of Black Engineers. So for this talk, I just want to go over the people, processes, and technologies that we can alter so that we create more accountable AI systems. And that way we can actually try to create equity and justice over reinforcing the status quo with data models that we create. I'll start with a quote by the author of Weapons of Mass Destruction, Cathy O'Neil. The privileged are processed by people and the poor are processed by algorithms. So unfortunately, we know that people are biased, but just because people are biased doesn't mean our models can't be fair. We need to understand first why many models can't just be debiased. It's not so easy to just take bias out of a data set when we are considering the historical constructs around it. And especially when we're looking at data like criminal justice data, it's inevitably going to lead to unequal outcomes because of historical data. And unfortunately, there's no ways to just account for that and to try and build fair models. So at least for people working in industry, it's important that we are like keen to the fact that it's not always the solution isn't always to use an algorithm for something. I think we have tended to think, okay, we have got a lot of smart minds in this room and access to technology and try to solve societal problems with tech. And unfortunately, we've ended up creating more problems than we have fixed. So I like to think about things from a risk perspective. So a step that most companies skip is really doing an in-depth risk analysis. So understanding, the different things that can actually go wrong with an algorithm, and then trying to measure what that worst case is. So we can think of accountability as a process that takes in uncertainty, the different objectives that teams may have, stakeholders and the different drivers and incentives, as well as like technological constraints. And then it also combines that with a risk mitigation strategy. So leveraging domain experts like social scientists, people that actually study how technology impacts society, and then basically creates a process that allows companies to genuinely be accountable. So what that means is, yes, they're transparent about the models that they use, but also there's an appeals process. So if you've ever been denied a credit card or denied a loan, there's a algorithm that was in use most likely to make that decision. And a lot of times the inputs it uses are factors about us that are really highly correlated with our race or our gender. So this can be zip code for one. In the US, zip code is really, really highly correlated by race. So it's really easy to say, hey, if you are in 90210, of course you have a good credit score when you're not actually looking at someone's personal merits. You're just comparing them to the people that are geographically nearby them. So in a lot of organizations, we have a really hard time balancing these goals internally with, the ROI they feel like they've invested in AI. And I think that's one of the difficult things to get over, because companies think, okay, we've put a lot of money into this, we should see a lot of money as far as revenue. And then a lot of data scientists or ML engineers say, yeah, maybe we shouldn't work on that. And it's a hard time, it's a hard thing to balance, because organizations aren't altruistic, right? Like they're at the end of the day still trying to make money. And people in these roles are trying to reduce the amount of harm that we cause, but trying to balance that with still providing enough new revenue so that our organizations don't start getting worried about the investment in AI. So one of the things that's difficult, though, is that AI's history should kind of be enough to convince us that our goal with data science and ML should be to create equity. So I'll go over equity a little bit more in detail later, but there have been a lot of talks that look like this. I've done a lot of talks that look like this. And I think it's hard because as a data scientist, I think that if I just show people the damage that AI can cause, demonstrated by like the news coverage of it, it's going to be enough to make engineers care. But that's not the root of the problem. It's not that like individual engineers don't care. It's that most are genuinely unaware in a lot of the ways that their products cause these biases, right? So one of the examples later is a voice to image generator that its input is your voice and tries to predict what you look like. While I'm sure some of the people on that project were really just unaware, it's hard to see that when you're in the dominant group, right? There's not really a lot of engineers that intentionally try to create an algorithm that has biased outcomes. So one of the biggest problems, especially in industry, is that data science workflows almost never allow for the kind of in-depth project assessment that stops these biased cases from happening at the beginning. So I've been in this situation where I am tasked with researching a whole new subfield of data science and given a week or two to produce a working model that is supposed to be out in the world and working on real data about real people. With that kind of pressure, there's really little opportunity to prioritize vulnerable groups, to actually do the kind of research and leverage the user researchers that you need to leverage. So we kind of just go forward with it, and then we end up with these like critical AI incidents and try to either backpedal or cover it up, right? So if we don't start shifting a lot of these organizational incentives away from just measuring, the return on investment for AI compared to, their perception of maybe over investing with high salaries, having large teams, if we start to shift these incentives away from that, we can start to create fairer workflows. So it's really difficult to solve this decision without companies completely buying in. And I think that's the root of this talk really, is that yes, I can educate individuals, but until we get buy-in overall, it's hard to be one individual who cares about fairness and equity at your organization and not really have that support. So one of the things that you probably have heard about, as of June this year, the Association for Computing Machinery urged lawmakers to suspend the use of facial recognition. And they basically cited the documented ethnic, racial, and gender biases. So a quote that I actually really liked was, they mentioned that the consequences of such bias can add to and do extend well beyond the inconvenience of profound injury, particularly to the lives, livelihoods, and fundamental rights of individuals in specific demographic groups, including some of the most vulnerable populations in our society. I think what's important about that is that we've unfortunately kind of perceived harm as a very trivial thing, whereas we are getting to the point where facial recognition is having people arrested. We're getting to the point where facial recognition is banning people from flights. And the problem, half of the problem lies within the fact that it's already a biased measurement. So if this is the case, I think we really need to start questioning, courses on computer vision that don't mention this. The ACM is a fairly large org. We need to start talking about specializations in computer vision that specifically cover this in graduate programs. There have been, since June, there have been, I'm sure, hundreds of talks, tutorials, paid courses, workshops that still teach the fundamentals of computer vision, but without mentioning what can happen. And I think that's difficult when we're in such a hot field like data science, because people are interested in the machine learning and the cool aspects without having to take responsibility and accountability for what their algorithms do. So I highly recommend that people really going into 2021 start reassessing how we view computer vision. We have enough documentation that the governments have been urged to not use this technology without further research. So it also does open a huge door for equitable and ethical computer vision research, but we need to have a bigger focus on how we impact people with what we do. So when I think about accountability, I think about it like a combination of a ton of other methodologies that work to keep companies who make ML models from shirking the consequences of basically meddling with political elections or creating surveillance technology or disproportionately policing over-policed communities. So this takes the awareness to identify risky models, patterns, as well as historical artifacts. So we have to be able to make fair decisions, understand what kind of fairness is important to us, and then test for fairness as well. So this is something that's not done at the vast majority of organizations, but truly finding the data about our protected classes and then seeing if we can replicate our model's bias, or if we can create counterfactuals for fairness, or test for fairness on an individual or group basis. Lastly, and most importantly, I see accountability as recourse. So this is a process that allows people to appeal these automated decisions, receive information about why a decision was made, and then they're able to understand how they can get a better outcome. If we're making decisions about people and not considering how they'll be impacted by the outcomes of our algorithms, we should be able to, at the very least, provide algorithm explanation. So explainability is really the first part of accountability. But even going further past that, it's really about transparency. So I mentioned an appeals process. There's no way to have this kind of a, automated decision system appeals process if we don't know that companies are making these decisions about us with machines. So if we, whether it's, an online form or a web page attached to onboarding emails, there's ways that we can build into our products ways for users to dispute these decisions. It's very rare that companies are actually truly accountable for these algorithms because there's no way for most users of their product to just see what they're using to make decisions about them and then call it out. So we kind of have to destroy the industry standard because a lot of AI has developed out from tech in general, out from software engineering. But the move fast and break things idea that works in software engineering scales so quickly and has the potential to harm so many in such little time with machine learning that we can't really take that approach when we're building these products. So the Institute for Ethical AI and Machine Learning provides 8 principles that provide a practical framework to support technologists when designing and developing systems that learn from data. So I'm going to go over these principles a little bit more in detail. The first is human augmentation. So this is human review of an assessment of risks. So this is where technologists can work with social scientists and really understand the harms that can be caused and outline what to do when there are unknown unknowns. As much as we try to predict the future with data science, we can't. The same way we can't predict the true harm that we can cause, but we can try and measure it and figure out ways to create mitigation processes before we build these models. And that would make a huge just culture difference in how organizations started to approach machine learning. So a lot of the social scientists, they're able to help technical teams outline how to capture this user feedback, set fairness standards, as well as architect new algorithms that their whole purpose is to create equity. Going into bias evaluation, we can assess risk, but we truly need to keep in mind that risk needs context, right? So to evaluate, we need to understand the bias in the data, as well as the systems we build, as well as the people creating these data models. So this really requires us to understand and document all of the sociological discrimination that is impacting our the way we build these systems. I think that unfortunately we have tried to ethics wash somewhat of AI by saying, we can be fair by being blind to certain things. We can be fair by not taking into account your race or your gender, but that doesn't truly fix the problem. There's still data proxies for race and gender. There's still other issues that are beyond these protected classes that we don't address when we try to just exclude these features we don't think we should use for predicting. Going into explainability, we're no longer at a point of development in industry, and especially in like high stakes industries, that we can experiment really loosely with deep learning methods on human data without building explainable and interpretable systems in. So we need to design models with the purpose to explain to a human being why a decision was made and not to necessarily achieve novel accuracy. So this really is a mindset shift, and we have to understand that people tend to believe computers. If you gave 10 people different weighted calculators and they put in any multiplication problem, you'll see that maybe two, maybe 3 people would see that the calculator is incorrect and then actually say something about it. Most people are going to just accept that answer and move on. So knowing that when we're working with any kind of automated decision system that's supposed to interact with human beings. So for example, the Compass recidivism algorithm, judges are supposed to be able to use that. And the way we have communicated these technical products is part of the problem. They should not be the algorithm should never be the final decider, right? The algorithm should be one input to a professional's decision. if you are a doctor and you're looking at an algorithm that tells you, different kinds of diagnoses for your patients, that should be one input into your professional decision. But the problem is people tend to lean on computers. We can push our human our faults onto the computer. So maybe we don't feel confident in the decision, and a professional is able to look at the computer and say, oh, well, this says that it's this, so it must be. We as like data scientists have to be able to design in algorithms in ways that the outcome should always be readable by a person, and the goal should be the outcome is something that they use as a single input into their professional decision. So one of the biggest barriers for having reproducible systems, I'm sorry, it's like 5 o'clock my time. One of the biggest barriers to reproducible systems is the lack of good documentation. So two methods organizations and people can start building into their data science workflows right now are by creating data sheets for data sets and model cards. So this is Google's example model card for its object detection algorithm. And what it really does is just show us very clearly the way we intend models to be used, the limitations of these models, as well as things like their performance. What's nice about this is, it allows us to be frank when communicating to stakeholders and users, not just the limitations, but things that are correlated with biased outcomes. So there's a lot of times when, production machine learning systems that don't have the capability to diagnose or respond effectively when something bad happens, it's really difficult to reproduce those bad results. So when we are in this evaluation stage, or when we are trying to audit these models, it's hard to get those same biased decisions out. But by having model cards, by pickling models, by making sure that we have actual model governance and model modeling when we're working with production models, these are ways that we can attempt to deal with these risk problems, as well as having a kill switch. It's extremely rare, but there's so few companies that can kill an algorithm that is, making biased decisions without, downing the rest of their product. When in the way that we have things like site reliability engineers, we should have people that are focused on making sure that these models can be paused, these models can be retrained, these models can be fixed in production without causing major damage to basically our company's working products. So as data professionals, we also have to think about the real human harm that can be caused if we are replacing human workers. So we've seen this happen, especially in warehouse cases. But really beyond that, we should consider how we can create alternative work options for people that have had their roles automated. So a lot of these workers have firsthand experience with phasing in automated systems. And in some cases, they're able to actually provide things that are really useful, like data annotation or decision monitoring, given specific job training. But we should be able to identify and document relevant ways that we can change business processes to mitigate the impact of the people that are going to be displaced by the technologies we build. It's becoming more and more apparent with the pandemic and with companies trying to bounce back from that, that we won't have every job come back to human. So when we are starting to build these automated systems, it is within our responsibility to start thinking about alternatives, work strategies, and trying to get our businesses and organizations to buy into alternatives for workers who are in those roles right now. I'd also like us to all consider practical accuracy a little bit more. So when we're talking about cost metrics and model evaluation, we need to make sure this is aligned with our domain. So this is really difficult because it is drastically different regardless or whatever, depending on the industry you're in. So it's not enough to just use plain accuracy. Accuracy doesn't really describe our how good a model is, right? So this is one of the hardest challenges because if we don't have the domain knowledge, like in medicine, to say, you know, we would rather have either more false positives than false negatives, it is really difficult, especially for new data scientists in new industries, to try and grasp what metrics are the most important. And at least in my experience, every time I have reached out to someone in product or in other areas of the company about the metrics that are the most important, the conversation almost always goes back to product or business metrics like clicks and engagement, and not the ways I should be able to measure my machine learning models. So to also get towards accountability, it really requires a lot of user trust. So both internal and external, both internal employees and then every person that works with data along the pipeline should have a really strong understanding of data privacy, especially the harm that can be caused to users, as well as the regulations and consequences of mishandling user data. So I know for me, my company is a credit reporting agency. So we have to abide by the FCRA. I became FCRA certified like last week. I can personally go to jail if I decide for whatever reason I wanted to just go in my company's data and look up someone's accident history. If someone's like, I want to see if my cousin has crashed their car and I go look up that person's name, I will personally suffer consequences. It's not like that in every single company. And I think that's one of the issues, especially software and internet companies have, are there's few repercussions for this behavior. And it's not to say that it's as rampant, but it's more so organizations are too lazy to properly train people on data privacy. More of these data breaches actually come from accidental human error than they do from hackers. So building user trust can be done by, you know, informing users not just of what data is being held, but also the models that their data is being used to build, that their data is going in as training data, or that their data is testing data for. We should also be able to demonstrate that we know why protecting their data is important and that it's actually meaningful to us. So I think we have a long way to go because we are still going to be battling a lot of the media portrayal of AI as this kind of overlord, but we have seen so many AI incidents that it's understandable why the public is skeptical, right? Going into like risk awareness, it's really important that autonomous decision systems allow, they allow for a ton of new kinds of security breaches. We need to have better infrastructure so that we ensure both our data as well as like model security is taken into consideration when we're building these new systems. So we just have to not only be aware, but understand that every company has a different risk potential. So the risk of a model created by Netflix to rank a movie is fairly low on the scale. Like the worst thing that could happen is you don't really like the movie. But when we're talking about government, healthcare models, housing, hiring, so many of these areas that we can actually have catastrophic damage if we have a model that is over and over denying certain groups, access to financial institutions or access to healthcare. It has catastrophic repercussions on society. So for teams, this kind of broadly covers a little bit of what I just mentioned. We should be able to assess the risk that we can cause in these 8 areas. But what's really important right now are disinformation and propaganda, the dopamine economy, access inequalities, surveillance technologies, and hateful actors. These are things that we have seen actually grow a lot within the past few years, and need to start thinking about more when we're actually building our models. when you are creating a new model to predict something about someone, it's good to start thinking about how someone, how a hateful actor would use that against them, how people with dubious intentions would turn your model that you created for good into something for bad. So in past talks, I've mentioned the mindset shift that we need to take in order to better serve humanity in general with the algorithms we create. So instead of optimizing for internal rewards or recognition, we should optimize for creating equity with our models, and we can only do so by, at the very least, having responsible AI systems. So what goes into responsible AI is really centering on the human, being compliant, obviously, with regulations, being ethical, or I like to think of ethics as fairness, um, being secure and actually keeping human data private, as well as interpretable and explainable. So a lot of us, we have to understand that when we're in these roles and organizations, we have to push back against the notion of scaling solutions as quickly as possible. This is one of the most damaging behaviors, and its incentivized habits essentially have led to a lot of the AI incidents in the past. Um, it's really rare that organizations discuss whether or not we should use an algorithm to begin with. So I think data science specifically suffers a lot from the Dunning-Kruger effect, where we may be excellent and excel in specific areas, but it doesn't always translate to every area. So we should not only assess if we should use an algorithm to begin with, but also if our use case comes from a discriminatory or colonial artifact. So when we think about surveillance systems, while you could say this is technically not, they're technically not biased algorithms, but they work within carceral systems that that are extremely disproportionate in their outcomes, right? So even in the use case, we should be critical of how we're using these algorithms to begin with. And the problem isn't just that data is biased. So it's the fact that we continue to use biased data to model the future and make predictions about people. We have to accept that there's historical artifacts that we just can't change. Policing data is overwhelmingly biased by race and highly underreported sexual and domestic violence. Healthcare data is rarely representative of the general population because of who seeks healthcare as a result of biased medical professionals, as well as hostile healthcare environments. So even financial data skews highly towards those who have access to banking, loans, and financial systems that women and a lot of racial minorities have lacked the exact same access to. So a lot of public data sets for facial recognition, and this is one of the reasons facial recognition is so flawed, they skew so heavily towards white male faces. So much so that even the University of Massachusetts Amherst faces in the wild data set had to be removed. They found it was only about 13% Black faces in the whole data set. So what you're looking at right now even is the monthly report for Plantation's Hope and Experiment in British Guyana. So even though this is from 1812, this handwritten tabular data was compiled and sent back to absentee slave owners who were living abroad. Even data from an era that I wouldn't be considered a human being is still, there's historical artifacts that tie to this, and so much of the data that's in existence today that companies still use to model and make decisions about people. So when we look at things like this, we have to take into account that data is biased and there's no way to just magically fix that biased data. What we can do is choose not to use certain data and choose not to create certain models, but people don't like the idea of being restrictive. They want to explore and then kind of curb based off of regulations and harm, but we have to understand that we have the potential to cause such great harm with machine learning, that it has surpassed what we could really do with most software engineering. It's surpassed the, the worst thing could happen being an A/B test on a push notification. Things are so much worse than that now. So a recent study actually examined the effect of a widely used but controversial algorithm for estimating kidney function. So this algorithm basically assigns Black patients healthier scores by design. So the study found that a third of Black patients, or more than 700 different people, they would have actually been placed into a more severe kidney disease category if their kidney function had been estimated using the same formula as white patients. So this algorithm is one of the many clinical decision algorithms that actually explicitly takes account of race. So in 2009, researchers actually were trying to reduce the disparity in the few examples they had of Black patients. So they actually added a race correction feature to a patient's EGFR, or it's a blood test that measures kidney function. So this correction actually boosted the EGFR numbers by 16% for all Black patients, regardless of their individual medical histories. And they didn't do this for patients of any other race. So this actually ended up having a drastic toll on patients. So there were actually 64 cases where Black patients would have qualified for a kidney transplant, but none of them were actually referred for transplants or evaluated for transplants. So what I'd like you to think about is, what would you do if your family were on the kidney transplant list? What would you do if they found out they were less likely to be selected just because of their race and no other factors about them? If we know that race can be explicitly coded in this way, we have to not just be aware of these things, but start teaching students, especially, not just about cutting edge technologies, but how it can actually be life or death. So a big key to successfully mitigating ML risk is real accountability, but that comes from building it into most of our team's cultures. We need to start asking things like, who tracks machine learning, how is it developed at our orgs, and who's responsible for auditing these systems, and if we have any plan to respond to AI incidents. For most companies, the answer to that is truly no. If no one's job is on the line when these systems fail or get attacked, it's possible that no one's really thought through these ML risks. When we look at so many other similar industries, we have site reliability engineers, we have people in software engineering who work on shifts to fix these issues. We don't have a lot of that embedded as far as AI culture. And so I like to, tell teams as well to think about dog fooding more and steal that aspect from software engineering, where, it's really about just using your own product. More importantly, a lot of what it does is it brings these like legal and risk questions to the forefront. So, if your company has developed an ML system that you wouldn't want to use, or it's in fact breaks your privacy policies, it's easier to raise concerns about them earlier on when you have people internally testing them. And then when building these complex systems, one of the best ways to reduce biased outcomes is to actively challenge each question and step of the ML development process. So creating environments and cultures that enable people to seriously question the design choices that we're making, and then challenge the design choices we're making. Having these environments is crucial to actually having transparency and accountability. There's also a drastic need for demographic diversity on ML teams. It's no longer just a want or nice to have, but it really is, because the only way to assess and destroy all of the biases that are in these communities is to, or that our communities can cause with our products, is to have these people in our organizations and then be able to have them actually have a voice. But this only comes by, destroying the hostile workspaces that have kept people out. It comes from investing in a lot of institutions that are for Black and Brown and Indigenous people of color. It comes from divesting mentally away from these features that are really correlated with like elite universities. There's so many tech companies who are looking for people who've only have had papers accepted at like NeurIPS and ICLR, but that's not the only kinds of people who should be on these teams. We have a lot of organizations who, they want to put the Stanford or MIT or Harvard logo on their website, but that's not including everyone who is able to see the problems in the systems that we build. And going hand in hand in that, we still need professional diversity as well. This especially comes from the fact that technical people have historically had a really hard time trying to solve social problems with our technology. We need to be working a lot closer with people who are on the ground, people who are the domain experts in our industries. Like for example, my company, a lot of our clients are big fleet companies like Uber, Lyft, and Amazon Prime. One of the best things that I brought to my company was the fact that I drove for Lyft for 3.5 years, and I knew what it was like to actually be on the job, to only be making tips, to have to deal with cleaning my car and truly understanding that experience. It's not just because I related to Lyft drivers for no other reason, but I had actually been there. So actually being able to leverage people with drastically different backgrounds, I always say that it's much easier to train people on technical skills than it is to try and get people in technical roles or who have had really unique and closed off experiences from a lot of others that it's hard to convince those people that the problem exists. So it's always easier to teach people who have the on the ground experience, just new technical skills. And so model governance is huge, and huge pieces of that are both documentation and model monitoring. So model documentation overall is abysmal. When we talk about, not just our personal models, but big models maintained by big companies, we should not just, talk about the where, what, and why, but also go into, the personnel, the hardware, the actual systems that are that we're creating, and then create the documentation so that any new employee, regardless of technical skill, could come in and understand how the system works, understand how they can take over maintenance, understand the steps that lead into it and the teams that are involved. We need to start taking this approach with creating model documentation as well, because as we've seen at many companies, and especially during pandemic, there's massive amount of turnover. We have to be able to hand systems off. And I know I'm not the only one, but I'm in a company now that has existed for over 20 years, but has just now become a data company. And so much of the knowledge about the data that they were dealing with 5, 10, 15 years ago is just lost because people aren't working there anymore. This isn't uncommon, and we need to start preparing for this more often when we create documentation. And then when we're modeling or monitoring our models, we need to make sure that we're watching, not just for the inputs and the outputs, but how these systems are actually changing over time. So what's really common is that we have accuracy drift. So our model starts off really well for the first few months, and then maybe we're not updating it as much as we should. But for whatever reason, we're noticing our accuracy slowly decreases over time, or our fairness slowly decreases over time. So algorithmic discrimination is basically described as one of the biggest challenges for social progress in the 21st century. It's easy for deep learning models to find patterns based off of biases and not based off of facts. So this even happens with image data. And a lot of us kind of tend to assume that that's not really possible with image data, but there's actually a 2016 paper that showed a model was really accurate but untrustworthy when trying to discriminate between wolves and Siberian Huskies. And it was solely based on the presence of snow in the background. So as you can see, none of the actual features about the animal are being taken into consideration in this explanation. So it's not just historically biased data. It's not just human systems. This can happen when we don't think they do. This can happen with audio data. This can happen with image data. It's not just the data we initially think that is going to be biased that we can have this discrimination in. And I think, one of my biggest points is that we're going to accidentally end up creating the same bias systems, whether that's racist, sexist, homophobic systems, if we just build models without addressing them specifically. That's what happens if we do nothing. The do nothing option doesn't just equal fairness. So that also leads us to talk about discrimination a little bit more in depth for a moment. So in order to truly be accountable, we have to acknowledge like the historical artifacts of white supremacy and other biases in our data. We have to understand which versions of these things we consider socially acceptable by engineers. They are socially accepted in society as a whole, but these things come from the dominant culture. This is a huge barrier, not just in having like diverse data teams, but in having models that are truly fair across all of these protected classes. If you look at all of the things that are in this covert white supremacy or socially acceptable white supremacy, these are areas that we're actually using technology to try and fix, or technology is being used against people and actually supporting these white supremacist ideas. So this is from hiring discrimination to housing discrimination. There's so much in this that we kind of have to unpack publicly and corporately to really get to the bottom of accountability. I think that's the thing is accountability is really still about caring for our most vulnerable groups. And historically, when we talk about marginalized groups, it's mostly been Black and Brown people, disabled people, neuroatypical people who are dealing with the biggest impacts of this. And we also have to understand, it's more about the power structure than it is any of the isms, really. So one of the ways that I always like people to, I've always found helpful is to just think about the ways that you're oppressed. I know it sounds weird, but it's not just about race, right? There are so many factors related to non-dominant groups. This can be about age. This can be about, people from working class backgrounds. There are ways in which our technologies uphold this exact same structure. And if we don't start to understand, okay, not only ways that, we're oppressed or discriminated against, but ways that we can try and fix these things, ways that we are able to identify this is how things have been in the past. And by trying to create equity, trying to remedy some of that. So direct discrimination is a little bit easier to understand. It's basically rules that kind of impose these disproportionate burdens on certain groups. And they're as a result of, measuring their protected classes. So in most cases outside of healthcare, this is actually illegal by federal law, but it's easy to identify this, right? The problem is with indirect discrimination, it proposes these burdens, but it doesn't look specifically at things like race and gender. So these things are usually encapsulated in proxies like zip code for race. Weight is often a proxy for gender as well. But we have to move a little bit, we have to understand not just how to discover this discrimination, but what to do after it. So there's methods we can use to basically skew or first discover the skew in our data. And one of the ways to do that is to do classification rule mining, as well as K&N classification. So this whole data mining step should really be a lot of our step one when we're dealing with a new data set. We tend to look at things like our statistics outputs, describe data sets, and just have very broad stroke understandings. But it's very rare that we dig into the exact ways that we have these imbalances on protected classes. And then going from there, we're able to rank and then measure the discrimination. So what's interesting is there's methods to create synthetic discrimination so that we can actually reverse engineer them and try to make our models more fair. And lastly, we have to understand this idea of fairness, right? And what kind of fairness is important for the kind of use case that we're working in. So when we are trying to deal with this, discover discrimination, first we can attempt to get a better understanding or better representation of our data by trying to resample our data and reweight our data. And then in the model development process, we're actually able to use adversarial methods in order to reduce the bias, as well as specialized methods that regularize or downweight the importance of features that are correlated with our protected classes. And then we can also move into fixing our predictions. So in a lot of cases, if our adversaries can, right, our main models use information from the adversary. But then it's not using the explicit demographic information to downweight any of the hidden demographics information. So when we're fixing these predictions, we're able to assess models that are already in flight in ML systems and either provide them with new data, provide them with retraining methods to actually deal with this while they're already out there and existing in the world. So going into fairness, I've talked a little bit about this on an individual and group level, but individual fairness is really about consistency between similar people. So people with similar backgrounds would have similar outcomes. And where this gets difficult is that this doesn't mean they have good outcomes. This can be they're treated equally well or equally badly. So in terms of things like solo sports, like singles tennis, individual fairness would be if all of the players that were on Serena Williams's level had similar outcomes or opportunities to have the same compensation as well as exposure. But when we're talking about group fairness, this is about statistical parity. So this means there's an equal chance for people in a protected group to get a benefit as it is for people outside of that group. So this could be a scholarship, admittance into a program. And here's where we start to see a lot of algorithmic discrimination lawsuits stem from, because if we start to see that there's a large discrepancy in group fairness between protected classes, that's where a lot of actual lawsuits and algorithmic discrimination stem. So going into what we actually think accountability looks like, there are a lot of ethical principles and things that we need to consider here. But first, I think of it as taking responsibility for the harm that's caused by an automated decision system. So instead of companies kind of leaving users hanging, actually providing things that, regardless of if it's a monetary consequence or regardless of if it's some kind of a refund or a free month, but actually taking that responsibility and saying, yes, our decision incorrectly classified you, and here's what we're going to do about it. And the second piece is allowing users to really dispute these model outcomes, as well as evaluate the models. There's a huge need in general for model transparency, and users need to be able to understand and test it for themselves. We have a lot of citizen data scientists and people who are data savvy enough in the public that models shouldn't just be a company's secret sauce. We should be able to analyze them and basically critique them in the way we would, things like their website or their social media presence. They have a large impact over our lives, so we should be able to, at the very least, test them and explore them ourselves. So moving beyond accountable, let's say creating this is easy, right? Like, what do we do next? I think we first have to embrace that data science is political action. And next we need to, work to create equity. So if we become accountable and we take responsibility and we let users appeal our models, what do we do after that? And I think that's where we focus a bit more on equity. And so, using as an incentive in organizations, not just creating models that are good or doing data science for good, but doing this to actually create equity, especially in areas where we haven't had it. So when we're thinking about historical marginalization in terms of technology, it's typically been non-men and non-white people that have had algorithms used against them, have had biased data, allocate them fewer resources, especially with financial systems. So if we only create equality going forward, we don't really take accountability for our algorithmic oppression thus far, right? So equity is contested because it's relative, and it really just begs the question, equitable for who? And there's no like magic bullet answer. It's going to be different from company to company, but we should at least be able to, do no foreseeable harm, and then value justice. So justice requires designers and developers to think carefully about harm and then try to avoid harming users that might try to avoid harming users to begin with, and then finding ways to compensate or remediate for the harm that you do cause. So to sum things up, the steps that people take right now are really first to be able to identify this risk. So where does this risk live? And by that, I mean, is the most risky aspect of your solution the data? Is it the actual model or the modeling architectures you chose? Is it in the feature engineering? When we're able to identify where this risk kind of exists, we'll also be able to easily outline who it impacts. So measuring the vastness of our user group that gets impacted by these models. Maybe we are only, for a lot of product companies, segmenting really small groups of consumers, understanding both where it exists and who's going to be impacted by it is that first step. The second step is being able to measure this. So quantifying quantifying what this risk looks like, as well as creating instance response systems. So this is something that my organization's participated in recently, and really trying to understand when our model fails, who's in charge, who is leading the team to regroup, how do we create frameworks to stop new predictions from happening, and then what do we do about it? Do we abandon the project? So creating these internal teams, or just at least starting to think about these things when you're building machine learning models, is going to put you far ahead of most people who are doing this in industry. And then being able to mitigate. So understanding and leveraging our social science and fairness experts are probably the best way we can actually reduce this harm. It's really difficult, like I mentioned, for technical folks to see this. We can't solve it all. And I think we need to work a lot more in collaboration with people on these who are ethical experts to really come in and have more input on both our fairness workflows, as well as how we implement what this recourse or what this appeals process looks like. And then, having this process for appeals, the biggest issue here is really focusing on either these compensation standards or how we're actually going to deal with this problem. It's one thing to, organizations are keen to maybe just kind of send a quick apology email, but understanding there's different levels of risks. I think that's acceptable when maybe you get recommended a song you don't like on Spotify, but that's not really acceptable when you don't get admitted into the hospital. When we start to think about being rejected for job opportunities, there are ways that we can actually quantify damages and actually provide these damages to users. I do think the biggest thing that will be helpful here is hopefully some new regulation that actually requires companies to both measure this as well as actually compensate users that they've harmed. This is not, this is unfortunately not new. It's new in how vast and how quickly it's spreading. But especially when we're talking about being denied housing, how can you quantify what it's like for someone to get denied a place to live? These are questions that we can start thinking about as we're building models right now. And then I've got some other books up here that have really set most of my foundational knowledge in ethical AI and accountability. And that is it for me. So if you have any questions, please feel free.
Questions?
Feel free to unmute yourselves or drop it in the chat if you don't want to.
So I'll start with a question then. How would you recommend increasing like social awareness for for students who are technologically inclined? Like, is there any particular topic or class you would recommend they take to increase their awareness of, well,
yeah, I think it's hard. I can't say I have one specific recommendation, but I have like mental exercises that I do. It's very much about putting yourself in someone else's position. So it takes a good bit of open-mindedness and flexibility, but I have as part of like a user experience exercise with my organization, put myself in the position of someone who is our customer's user. So as a driver at Amazon Prime or at UPS, trying to understand, what, let's imagine what 5 o'clock feels like. You're at the end of your day, trying to put yourself in these positions. But I think it's difficult because we all have perspectives that have shaped who we are. Like it's not necessarily a bad thing, but it's very hard to see outside of that perspective. So I think I relied on leaning on people who are different than me, who have a different perspective, to kind of speak for themselves and just listen to what they have to say versus trying to make those assumptions, because it is kind of a murky line there as well.
So I just want to say thank you for coming and really focusing on this topic, because a lot of people don't want to be held accountable, and so talking about accountability, I think, is a really important thing to have, and like what you said, having people like engineering teams having flight accountability. I'm not sure.
Accountability by blindness. I don't remember what it is.
I forgot what you said, but it's just like the making the conscious effort towards that.
Yeah.
I don't know. Maybe it's like, oh, go ahead.
No, go ahead. I'm sorry.
I don't know if it's like this field, but yeah, That's just what I was gonna say.
I do think there is some resistance in tech because unfortunately a lot of the people who are in this industry have a very like elite education, upper middle class background. And it's not to say that that's a bad thing, but it is hard for them to. And I think about products like the Apple Health app, which it's like 51% of Apple consumers are women. And like it was like a year and a half before they thought about creating a cycle tracking feature. They're like, what? And when we start to look at the demographics of these teams, we can understand why. We can understand, you know, even especially with the recent news about Google, it's like 1.6% of Google's workforce is Black. So when we look at Google products and we look at how their engineering team builds these products, no, we can't say that it's equitable and that they are able to truly build for everyone. And I think that people feel like, okay, well, I have to just learn the quirks of everyone, when we're like, no, just listen to the users, listen to, you know, be conscious enough to ask. And then when they tell you, actually interpret that in action. Don't just say, okay, yeah, like you guys don't like this, but we're going to build it anyway. And in my experience, that's unfortunately what it's been like. So you brought up a huge point in that we just have to leverage a lot of other experts and think about it less of a strict like kind of engineering job and think about it. I try to think about some like truly scientific elements when we're doing this kind of work, and not just building new tools, but you know, creating things that have drastic importance. So yeah, we've got some work to do in being accountable. I personally think that we should have something similar to not just like the Hippocratic Oath, but have personal liability. And no, it's not exciting. I don't want to be sued. I've made a ton of mistakes, but I think when we start to think we can cause like life and death, you know, consequences, if companies as a whole don't want to take that responsibility, we either push it to individual practitioners or the companies take accountability. I feel like we kind of get stuck there.
There's a question in the chat. Arby, do you want to read it or do you want me to read it?
Actually, I have an additional question on the topic we're on right now first.
Okay, ask away.
Yeah, so in terms of, you know, if no one's job is on the line, then no one cares, essentially, you know, the kind of tragedy of the commons, essentially. Would you say that policy development would be a way to address that, you know, if you could regulate in that way, would that help?
Absolutely. Absolutely. So to be honest with you, I wrote this talk before the election. So I necessarily was not in the place that I believed policy would happen. That has changed a good bit, but I do think that that is the biggest way to not put the burden on individuals, is to have it be at least like a GDPR at the very least. But then even going past that to say, yeah, there's actual, you know, substantial monetary consequences for making these violations, or the idea of like an FDA for algorithms has been tossed around, and having a truly third party bias or sorry, auditing kind of organization, I do think is one of the best ways to approach this. So I do think we've got a good chance of getting some of this passed soon.
Wow, yeah, that's interesting to have a third party testing. That makes a lot of sense. And yeah, to have some kind of monetary repercussion, that's the best way to go about getting people to understand the concept.
Yeah. And I think that that's the thing that speaks to companies is, okay, if we are getting fined enough money that it is chipping into, it actually hurts, then maybe we'll actually dedicate teams to fixing these problems.
Sure, as soon as it starts to affect profit loss.
Yeah.
Yeah, so my other question was kind of about the steps that you just went through. In step 3, your mitigation step, you kind of talked about leveraging social science for workflow development to reduce harm. So is that just like kind of theoretical in the basis of how you develop the workflow, or do you mean to include an actual social scientist on the design teams, or like an ethical expert?
I mean actually including them on the design team. So this is actually a process that I've been working with some freelancers on really how to get these people embedded in teams in ways that teams can say, this is how we've done things in the past. You know, what they're able, so what social scientists are able to do are then try to understand and measure this past risk and then say, okay, so going forward, how do we change your workflows? Do we, before a model, let's say, goes to production, do we have a step where we add another layer of internal testing? Maybe I'm shocked that this, I actually found this out recently, but there are so many people who end up building and training production enterprise ML models who have not seen what the actual data looks like when going into the models, who have only been able to test on historical data and don't have access to that. So when it's about redesigning the workflow, sometimes it's additional steps in research or in prototyping. And sometimes I've actually been able to have fairly technical social scientists and ethicists work with me on how to basically prototype, how to test different model architectures based on the specifics of like the industry I'm working in. So it's a little bit rare, but these people do exist, and I wish we had more of a chance to leverage them almost in, we don't think about them. Like we kind of have this mentality that like a data team is like, you have an engineer, a scientist, an analyst, and maybe, you know, a couple other people, but I don't think we've truly embedded like domain experts on our teams enough so that they would pick up some of that technical knowledge and be able to advise us in those ways when it's about like being responsible with our products.
Yeah, there needs to be like a paradigm shift between not just, you know, what we're capable of doing, but who should be involved in the process of doing it.
Exactly that. And I would even say going further into including people who are more likely to be in your user pool who don't really have any affiliation with your company. So one of the examples, it's not a great example, but Google was trying to fix a lot of their facial recognition issues by collecting more data of people who have darker skin. And their methodology was, let's find a ton of homeless people and pay them $5 and give them a $5 gift card for their picture. And that's not the most transparent. Like, I think that's the worst way of going about trying to fix a bias problem. So it's including the people who, you know, they might be in an unhoused population. They might be someone who is on food stamps or doesn't have a cell phone or is not really included in this like technological digital revolution. There are ways to be ethical about including them in this research process without being demeaning or without like taking the worst road to doing that. So not only should we include those experts, but still including like people in these vulnerable populations and paying them for their time and in a way that is valuable and equitable and not being really deceptive about it, which I think was the biggest issue with how Google went about that.
Yeah, wow. Thank you so much, though. This was a great talk. I loved it. I appreciate that you started with the quote from Cathy O'Neil. I loved her book.
Yes. It's interesting. I read her book, like I was almost done with my master's in data science, and I was like, what? This is a problem? Like, I'd gone through so much of my program and hadn't fully realized the extent that bias was kind of infecting our system. So awesome, Bob.
Right, that also highlights a huge oversight and that you were almost done before it became apparent that there was an issue here.
Yes, and I will be the first to admit, like, I genuinely wish I had like talks like this when I was in school. I read Weapons of Math Destruction on my own volition about my last semester, and then I actually went to the Data for Black Lives conference on a student scholarship like 2 weeks after I graduated. And that was the first time I truly realized the extent of these problems, that it was in environmental, housing development in Miami, looking at, the impending like environmental changes and how that's impacting how developers are buying real estate. I didn't realize until going to that, it's in healthcare, it's in so many of these fields that it's so pervasive. So I understand. I'm glad that you guys are hearing this now versus kind of being totally done with it and being like, what?
Yeah. Like, again, thank you so much.
Thank you. Thank you for having me.
Thank you. I think if there's no more questions, I think that's a really nice way to end it. I think this really nicely bookends this semester. Those of you who've been paying attention will notice that we started with ethics and fairness in AI with Trisha Mahoney talking about IBM's AI Fairness 360, and now we're ending with today's about accountability, and that is on purpose. I very purposefully targeted people to talk to you guys about biases because I know UH doesn't have bias training in any real form, let alone in terms of AI and machine learning and data science and stuff. So I, very much appreciate that we were able to bring in speakers and talk about this, and that you guys are so you especially are so out there and vocal about this issue and all of these issues, and so I very much appreciate that you were easy to find and contact and invite, and that you were so willing to share your experience.
Absolutely. Thank you so much again for having me. I am so glad you guys stuck with me through all of that, because I know it's like, what? For a second. But thank you again. Seriously. I hope you guys have an awesome, wow, you guys are probably at the end of your semester. Yeah, almost. Yeah. Have a good semester break. And yeah, thank you again for listening.
Thank you.
Have a good night.
Thank you so much.
Thank you.